All right, I'd like to talk a little bit about electron configuration and kind of summarize what you've been learning in the videos for the last few days on electrons and electron configurations and orbitals and orbits and all this sort of thing and what's going on and how we use this. First of all, understand why we look at this. At atomic behavior, the way atoms interact with one another is very dependent on the electron configuration. If you think about it, when one atom comes into contact with another atom, it's their outer electrons that are interacting. You know, the nucleus is very buried down in there, and the inner electrons even are very buried down in. So a lot of the interaction behavior really is dictated by the electron and electron configuration or electron arrangement. So it's important you understand what's going on with the electrons. Now, to do that, there's a couple of issues that need to be addressed. One is typically in middle school, and a lot of people look at atoms this way. I call this like that Jimmy Neutron model, or if you ever watch The Big Bang Theory, they show the electrons going around the nucleus of the atom. It's a very, very common way of looking at the atom, that you have this nucleus in here, which, by the way, this is enormous. Normally, if you were sitting in my classroom and the nucleus was the size of like a penny, the electron would be the size of a grain of sand, and it would be across the street. It would be over near Calvary Baptist across the way, for those of you who know our high school. So there's a great deal of emptiness, a lot of empty space here, and a lot of distance between the nucleus and the electrons. But again, it's a visualization that people use. You picture the nucleus, and then you picture these rings where the electrons are going around, and you put 2 in the first, and 8 in the second, and so forth, 18 in the third, and so forth and so on. And it's a very common way of looking at it. So it's not really a bad way of looking at it. The problem is the 1900s went along and they started to understand more and more about electron and electron behavior. They realized that this model is not accurate. This is not really what's going on. A couple of things that you need to recognize. One is a guy named Werner Heisenberg. And you've heard of Heisenberg's uncertainty principle, which basically is saying you basically can't see an electron. If you look at it, you're going to need radiation that is small enough, light, if you will, that has small enough wavelength that would allow you to resolve and see this electron. But the problem is that's going to have so much energy because of certain rules that in seeing it, you're going to be moving the electron. You're going to knock the electron loose. So effectively, we can't see an electron. We can't really look at them visually and see what they're doing. So we treat them as a mathematical wave, as a probability function, if you will, of where you're going to find the electron most often. And so what we look at now are things more like this, or the one you see over here. We look at where the electrons are as more of a fuzzy cloud of probability about where it is. If you pictured me putting a dot on a fan blade and turning on that fan and taking a picture every so often, at any one moment, you wouldn't exactly know where the dot is, but over time, you would develop this kind of picture of, if you put all the pictures together, you would know, well, it's definitely within this circle somewhere. And that's kind of what we're doing out with electrons. It's a probability, so it'd be like if you took a billion pictures or something of an atom and could see the electron each time, you would start to get kind of these fuzzy dots, and it would fill in and become kind of dense in certain areas, and that's what we call the electron cloud. And it's really just a probability of where we're going to find the electron. The other thing that's somewhat frustrating for folks is the shapes of these things are odd. It's not, you can picture this nice circle because we picture the planets going around the sun. What we really get are shapes that look kind of like this. They're somewhat unusual, and there's dumbbells and dumbbells with hula hoops around the middle and all kinds of strange things. So you get kind of a wide array of shapes as well, which also adds to the complication. Now, let me kind of break this down a little bit and kind of show you what's going on. First of all, when you put electrons into an atom, they will always fall to the lowest orbital or lowest energy level first. They always fall all the way down. Once that level is full, they go to the next one and the next one, and they kind of work their way out. The first energy level, and you can kind of see this, and you can use the periodic table to know the order in which these orbitals are filled. The first 2 electrons always go into what's called a 1s orbital. S orbitals are always spherical. They're always round, and you can kind of picture it here. The nucleus would be in the middle of this. The next 2 electrons, this can hold 2 electrons, and by the way, they'd be spinning in opposite directions. Once that's full, the next 2 electrons are going to go into the 2s. So my first electron goes here, my next one goes here. Now my 1s level is full, so now I'm going to go to the second level, which is broken into 2 sublevels. There's an S and a P. So notice the first energy level has 1 sublevel, it's an S. The second has 2. it's S and P. The third has 3 energy levels. There's a 3S, 3P, and 3D. The fourth energy level has 4 sublevels, 4S, 4P, 4D, and 4F. The fifth would have 5 and so forth. So the energy level tells you the number of sublevels that you would have, and they always go in order, S, P, D, F. They don't fill in that order, but that's the order in which they go. Now, once that 1S is full, your next 2 electrons will go into the second energy level, because now my first energy level is full, and the first 2 will go into the 2S. The 2S is also spherical, it's also round, but it's bigger than the 1S. So if you picture this as my n equals 1, my 1S, that's the blue dot here in the center, and this is the 2S. So notice that my 2S is also round just like my 1S, it's just bigger, it's farther away. And if we go, and you can kind of see the progression over here, if we go over to the 3S, that's even bigger than the 2S, and then the 4S and so forth. They just get bigger, and this one's big enough that you can kind of see the layers, the red and blue layers. By the way, I got all of these from Wikipedia. I want to give credit to Wikipedia for all of these. Now, the next sublevel is called the P sublevel. You notice it's a little bit wider because the P sublevel holds 6 electrons. It has 3 orbitals, the PX, PY, and PZ. Now, they are dumbbell shaped, and again, if you were to actually look at them, it looks kind of like this. It's kind of a fuzzy cloud. They usually put a hard surface over 90% of the dots to give you kind of more of a shape, so it looks kind of like a dumbbell or something along those lines. But there's 3 of them. There's a PX, PY, PZ, and the reason they label them like that is because they're oriented in the X, Y, and Z axis. So your entire P is made of 3 of these orbitals. Now what happens is as I put my electrons into a P sublevel, they will go 1 per orbital first. So I'll do 1 electron in the first P, 1 electron here, and 1 electron here. So they want to spread out. Then they're going to come and start pairing. So then I'd have, this would be my 4th electron in a P sublevel. It's going to go here. Then my 5th would go here, and my 6th would go here. Once that's full, I've now, if you come back over here, I put 2 electrons in the 2S. I put 2 electrons in this P, this one, and this one for a total of 8 electrons. Now in middle school or whatever, you may have drawn a circle and put 8 electrons in that second energy level, which is a very convenient way of viewing this, but this is really what it would look like. That whole second energy level is going to be made of, so far you've got a 1S, and then you've got this 2S, and then you've got these P's. Now, when we get to the 3rd level, you have another S, again, just bigger than that first one. So, you know, there in the center, in the little centers, you see your 1S. Then we've got our yellow 2S, you can see it here. And now here's my 3S. Again, it's just a little bit bigger. Then we're going to start putting electrons into the second, or the 3P, which is the second P level. And you'll notice, you can kind of see it here a little bit. In the middle there, you'll notice there's your 2P. So notice your 3P, same orientation, just bigger. You can also see it here as kind of a fuzzy cloud. So then my electrons will go into the P. Notice your first level, the S has 1 orbital. Your P has 3. The next one we come to is the D, which is 10 elements wide because it will hold 10 electrons because it has 5 orbitals. Each one of these again holds 2 electrons. The shapes again are rather odd. This one looks kind of like a P with a hula hoop around the middle, and then you've got these 4 that look like cloverleaf shaped things, just in different orientations. But again, each one will hold 2 electrons. So each orbital holds 2 electrons. So I put 1 here, then 1 here, 1 here, 1 here, 1 here. So I'd be halfway through a D level. Then I start pairing up. Then you'd put 2 here, a second one here, a second one here, a second one here, and so forth. So the entire D will hold a total of 10 electrons. When we get to the F, there's 7. So notice it goes odd numbers. S's are 1 orbital, P's are 3, D's are 5, F's are 7. The shapes again are even stranger, and you get all kinds of odd things here. But again, you would put 1 electron in the first, second, third, fourth, and then you start pairing up. So you end up with 14 total electrons. So that's kind of a basic explanation, kind of a summary of what's going on. Now, the order in which these fill get a little mixed up. And so what ends up happening is the first 2 electrons will go in the 1s. The next 2 will go in the 2s, my little bit larger circle. My next 6 will go in the 2p, that's these guys. Once that's full, my next electrons go in the 3s. And notice I'm just reading along the table. Anytime I'm in those first 2 rows, I'm putting them into s orbitals of some sort. Anytime I'm over on this part of the table, I'm putting them into p orbitals. That's columns 13 through 18 on your table. When I'm in the middle area, the transition elements, which is basically columns 3 through 12, I'm putting them into the D sublevels, that's these guys. And when I'm these guys, these are down on the bottom. These are your lanthanides and actinides down on the very bottom. We've put them up here so you can see the order in which they fill. But those guys actually belong between columns 3 and 4 in your periodic table. So if you're showing where the electrons are going, they would go in the S, you'd put 1 in the D, then you'd fill the F, then you'd come back, complete the D, and so forth, and you'd go across. But this is the order in which they fill. Now notice, if you're looking in the 4th row of the table, you go 4s, but then you go 3d, then 4p. If you're in the 5th row of the table, you go 5s, 4d, 5p. So notice that if you look at the rows, the s's and the p's that you're putting the electrons in are the same as the row you are in. The D's, that transition area in the middle of the table, are always 1 less than the row here. So if I'm in the 4s, I'm putting them in 3d. If I'm in the 7s, I'm putting them in the 6d. Now when we get to those F's, those guys down at the bottom, notice they're 2 less than the row. So I'd go 6s, 5d, 4f, going to finish that 5d, then 6p. So again, notice the s's and the p's match the row that you're in. So one of the problems is it's not that I fill the entire 3rd level and then do the entire 4th and then the entire 5th. These levels start overlapping based on energy, and this is all based on their energy levels. So they do overlap. So what that means is a 4F is lower in energy than a 5D, which is lower in energy than a 6p. So again, they go lower energy first. That's where the electrons go. They always fall to that lower. We call that the ground state first. And then the next electrons would go higher up. When you are putting them within individual orbitals, you always go 1 per orbital, and then you come back and start pairing up. So that's kind of a basic summary of what we've been doing over the last couple of days.